No problem. We can go from first starting onwards. No problem. Now, thank you, Kastur, for helping me.
Welcome.
Mm. So see here. So I have given, I have just selected a particular Uniprot ID here. Just run the I have running blast. Okay, I'm running blast. I'm running the blast, and it is showing different organisms with the same protein ID. This protein ID is belongs to Mycobacterium tuberculosis, but I want to see, I'm searching this particular template. Okay, this template sequence to align a sequence and also to build a protein model. That's why I'm finding a template which is similarly available to the target sequence. Okay, so what I'm just finding, I'm just searching the blast analysis. In case the blast in uniprot, you can able to find in different organism the same protein. But in case like a blast P analysis, you will only find the relevant organism information only. Okay, is it fine?
Means similarity in two different organisms can't be compared. Am I right?
You can compare. You can compare not only two. You can compare more than 5, 10, 20, 50 also.
For in
Okay.
case the motifs for in case if we take Mycobacterium tuberculosis, the motif present in it can be compared to another organism using this.
Yes, that's what we are going to do here. That's what,
Okay,
that's
okay,
the
okay.
thing only. That's
I'll
right.
see.
Okay.
Okay.
Hmm? And see,
Yeah. Okay.
I want to search a template here. So there are many templates are available in different types of organisms. At that criteria, what I am doing, I will just go with the identity which is having more than 30%, which is the highest identity is available. I will search that particular organism for my to build a template. Okay, to build a model. So I have a target sequence. I needed the template which is having more than 30%. Then I can able to build a model structure. Okay, so that's why I need to select the which is more identical percentage. So now you can see here that Enterococcus fecalis has Enterococcus fecalis has 37%, while the Homo sapiens has 31%, and Phytococcus has 30%. You can see Thermoplasma has 31%, and remaining Pseudomonas has 24%. This is not, even we can't able to consider for modeling this type of sequences. So that's why what I'm doing here, I'm just going for this particular one. If in case if this Homo sapiens also having the identity is 37%, in case the Enterococcus is also having 37%, at the criteria what I have to select, you may have some doubt, right? In that criteria, you have to select the e value. Based on the e value, you can able to check whether which is the having the lowest e value, the lowest score for expected value. You can select that particular alignment. Are you getting what I'm saying? Is it clear?
Yes.
What about Arvind? Are you following me?
Sir, identity should be more than 33%.
30%, not
30%.
33, 30%.
And U value should be lower.
1 minute. So always remember that identity should be 30% above, and more which is having the highest identity that will be selected. And the other thing is what the if it is identity having the similar in case of two templates, then we have to go for e value. E value always should be lesser. You can see here the e value having 7.9, but here it is 2.6. Then at that in that criteria selection, I will select this particular ID. Okay, is it clear?
Yes.
Yeah.
Okay, yeah, fine then. So up to blast similarity search, are you okay? Are you able to understanding everything, right? So let me go for a sequence similarity then. Okay, so I just go for a similarity search now. I'll go for something like sequence alignment now. But we'll go for demonstration and hands-on demonstration for this cluster X. So now see, I just want to see something a protein called insulin in different types of organisms. Okay, there is an organism called insulin is available in Homo sapiens. It is also available in rats. It's available in Drosophila. It's also available in Sussascrapa. That's big. And so it's also there in frogs. So let me take some 4 organisms. Shall we download any 4 organisms? Okay, I just take this one. That is a Homo sapien. The other one was mouse. So the other thing was like Sussascrapa. And let's see the Cinorobacter elegans. So 4 sequence I have chosen. Okay. So now what I'm going to do here. So let me take the sequence, the FASTA sequence. This was the FASTA sequence. Just select it and make a folder. So I'm just making the folder that's called drug designing. You can so just save it in the WordPad as a FASTA.
Like the same way you did yesterday?
No. Yesterday I have not done anything.
No, you from PDB you saved in Word, not that one.
No, that is not this one. I am talking about Uniprot
Yeah,
FASTA sequence. This is belong to
Now we
Uniprot
are talking about
information we are
Uniprot, but the
discussing today.
saving procedure is same, I asked.
No, not that like that. It's totally different. Okay, now I am taking the second one was a mouse. So just go the down, just save it. After each and every alignment, next alignment should start with the starting line. Okay, go for the down, and after that, come to the next slide. So it is having only 108. So let me take this 108. So the other one was Senera by elegans, the FASTA sequence chosen. Okay, I just saved it, everything. Okay, save it in the FASTA format always. Okay, so this is insulin sequence. So I'm saving a name as insulin as FASTA. Yeah, tell me.
So the 4 organisms FASTA sequence you are pasting in Notepad one by one, correct, sir?
Yeah, right, exactly.
Okay.
Yeah. Okay. So even I think, are you familiar with Mega, Arvind?
Quite familiar.
You are
Because
familiar with Mega.
at once we did it using for phylogeny analysis we did it, sir.
Okay, I'll show you that one also. What's the difference here? Okay, why we are choosing this thing?
Okay.
I just saved in FASTA format. So I just close this one. Let me see it has saved in FASTA or not. You can see in the FASTA format. It's in FASTA format now. The entire element is in FASTA format only. The file format is for FASTA format. Okay. Now just go here and open the cluster. Okay. After opening cluster, go for file, load. In file, just select load sequence. It will be no open will be there. You have to select load sequence. Load. Okay. Go for the desired location where you have saved your name. I have said is a drug designing. So it will be find it with this name, the FASTA, insulin as FASTA file. So can you see this one? All the sequences has been loaded. Still alignment has not yet done. Okay. So I'm going for alignment. Go for alignment. go for output format options. In alignment, go for output format options. What are the format options you want to generate? Okay, select it. You can save all these alignments. And if you want to see any output order alignment input, you can. If you want to see numbering, you can also just save it. And after this, you have to make it as alignment should be done for complete alignment, not for the particular region. You are doing the complete alignment. Okay, just go for complete alignment. So whatever the alignment files you have selected as output format action, those all will be generated here.
Sir, can you repeat it again, sir? This step, how
What?
did you do it?
So see once again, go for alignment, go for output format options,
In
right?
that last itself, in cluster, you are doing job. And you are
I'm not
pasting
get
the sequence.
what you are saying.
No, sir. After going into cluster X21, you are uploading that file, right?
You have to paste all those things in one particular file. Okay, that may be in Word format, WordPad or Notepad, whatever it may be.
Okay.
Save it the output file in FASTA format. Okay. After that, save the where you are going to save the file. Go for file. Okay. Go to the file. Load the sequence. So the folder where you have been saved the file in one particular file will be there. Now all the sequences. Just select that file and open it. Then it will open in this way.
Okay.
Then you come to the alignment file and do the output format options. Select all the files. Because why I am selecting these all files? Because to if you want to do modeling, okay, in case like Mega, you are not going to find the PIR file format. Okay,
Okay, sir.
this is required. In case in Mega it is not possible. Only it is possible in cluster. That's why I am doing here. Okay, without
Yes,
going
sir.
for Mega. Okay, after selecting these all things, go for do complete alignment. Okay, select OK. So all files will be created. I see all the files are created. You can see their files, everything. So all the similar residues, whatever having the similarity in the sequence alignment, you can find all the sequences will be aligned. So you will be also finding something like this representations. So you can see the star mark. The star mark represents in all the human and mouse, pig and Cinnabar elegans. This particular amino acid was having similar not it is identical. Okay, all are identical. In case for this colon, you can see the colon. It is similar in representation, but there is a difference in pig. Okay, when it comes to the single representation, this is conserved. Okay, there was a something conserved residue is also available. Okay, this is the analysis what we can see. And also after that, go for file and save the sequence. Okay, after saving the sequence, write the alignment as PostScript file. Why it is required to write an alignment as PostScript file means, if you want to represent your picture, okay, so you can see if you want to represent in this way, this representation, you can go for write alignment as PostScript file. If you write the alignment as PostScript file, you will find the output will be generated in the PostScript file in PDF format. So if you double click this PS file, the RL PostScript file, you can able to generate the PDF file, and for further any presentation, research presentations or any poster presentations, you can able to make sure like this for representations. Okay, are you able to understand what is what I'm saying? Arvind, is it okay?
Sir, will you please again repeat the meanings of star, colon, and
So star was if it is having Identical sequence in all the in all the organisms, the star representation will be there. If it is having double quotation, this is similarity. Okay.
Okay.
And this is very this single one was called as conserved. Okay. And this representation of the single lines will be there. Those are called as gap penalties, because those doesn't having the sequence similarity at that particular position.
Okay.
Is it okay?
Same color represents similarities, no?
Not same color, same amino acid should be there. You can see, you will find here something called you need to see all those things should be similar. So you see, all are phenylalanine only, proline only. In all the residue, all the organisms, proline is available at this particular
Is
region.
that LVIM?
You have to see in this way, horizontally, vertically. Sorry, vertically, not horizontally. Vertically, you have to understand.
But
Okay.
it's showing same color, no?
Same color represent the same. That's the thing also similar, but you have to understand based on the representation of the identical symbol. So star mark. See here also same color is available then.
Yeah, I mean it's showing the same color for the 4 organisms. Then what is the meaning of that?
That's
Why?
sometimes they are very similar. That's it. That particular region has similarity. So we can't align it, na? Everything. As basically when you are watching, where is the particular region is aligned, we can't understand. So for that sake, we are aligning these all things. We are choosing the cluster tool. And if you want to see what are those residues, if you want to see such type of residues here, there will be residue numbers will be also noted. Then you have to make sure that you have to select this PostScript file. Okay. You have to double click it. If you double click, it will automatically generate the PDF file. But in case there is no dot reader in my original file in my desktop, that's why it's not opening. If you do double click, it automatically regenerates the dot file, PDF file. Okay. And if you want to do modeling, then you have to open the PIR file. This is the PIR file, how it looks. If you want to make modeling, you have to open this file and you have to edit the alignment. Then only you can able to generate model. Is it clear? Is it clear? What about remaining people? Arvind.
Sir?
What about remaining people? I'm waiting for the answer. I'm just waiting for the remaining people, what they have understood or not. I just want to go for further.
So doubt in this only.
Yeah, you can ask me.
Actually, I'm trying side by side. Don't mind. After selecting the organisms, what I have to do?
Which one?
First, I went to the Uniport, and after that, I typed a protein name, and on that name, some organism shown. And after that, I have selected 4 organisms.
Yeah, you can you select the FASTA sequence, then you go for save it all the FASTA sequence in any Word format file, okay, text document, and save it in
You have to
FASTA file.
open each and every.
You have to open each and everything. Yes, each and everything. See, each and every file you have to say, copy everything. You have to save in the text document. In this text document. Okay. After saving the text document, you save as it in FASTA file. So FASTA file is nothing but whenever you are saving any name, do dot FASTA. Okay. So when you are doing FASTA, give any name. So think something like Kasturi. Dot FASTA double quotation. Just close double quotation. Whatever name you want to give. If you save it, it will save automatically in FASTA format. Can you see? It will be near the type of the document will be in FASTA file always. Is it clear now?
If you don't mind, can you brief once again, please? After selecting the organisms, what should?
Right. This is the sequence I am selecting. Okay.
Yeah. Just have to paste in a notepad first.
No, either notepad or wordpad, whatever it may be. Okay. Save it. And after give enter, give and save one more sequence here. After that, how many sequences, n number of sequences are available, save it, paste it, go for file. Okay. Without save, go for save as. Okay. After that, go for string, give double quotations. So if you want to save any one of the name, any X name, save it, go for FASTA. In which format you want to save the type of document? After you have to give it in .FASTA format.
Okay.
Okay, if you save this one, you will see here the type of document
Okay, sir.
that will be available here. You have to choose this file for this particular file, this particular type of format file to the cluster legs to align the file.
Okay.
Okay, is it clear?
Yes, sir.
Yeah, fine. So if you have any doubts also, you can you feel free. Don't get don't think like that. We will clear. I can able to clear you. Okay.
Okay.
So what about Preeti ma'am? Are you cleared?
Yeah, actually, but the saving procedure is the same for everything.
Saving procedure is same for everything. Depends upon the type of document you are saving, the file format, in which extension you are giving. It depends. Sometimes it may be different. Sometimes I will be saving in LFI. Sometimes I'll save in mega format. Sometimes I'll save in Python script file. Sometimes I may save in a R script file. It depends.
Okay.
Whatever tool you are using.
Okay, fine.
Some tools are this cluster tool chooses only FASTA file. For mega, it chooses mega format. So there will be different things.
Okay.
What about Arvind? Arvind, is it clear for you? The cluster? You are saying some. Yeah.
Hello,
Okay.
sir.
Yeah.
I'm Sampada. Actually, I joined late. So I was joined late. So I didn't get anything. What should I do now?
And one more thing, I request you all people. So if we are every day at 7 p.m. our class will be started. Okay.
Yes,
Except
sir.
Saturday and Sunday. The other thing is, I request you. Siddhi is available for everyone. She will be sometimes she may be traveling, so she may have not been responded to you. Any of you. Whereas Preeti ma'am, she was also asking that Siddhi has not texted back. Later she
Yeah.
has responded to everyone. The thing is, she may be completed her office and she may moving to her home maybe. Okay, that's why she may not responded you before. From morning to evening she'll be free. The thing was, everyone who were registered for this course, you will be provided one. What I mean was this read my course user account.
Okay.
Okay, for everyone there is a dashboard is available. Okay, there is a dashboard is available. So for everyone there is a dashboard is available. Your user details will be available here. So you can also find the everything like see here I show you your account has a previous class sections, message, student, what are the study materials if we are providing anything, not only in this course. So all the details of this course information will be available. And the other thing is, if you have not cleared the previous section classes, if I have not provided any videos to you, so don't worry for the previous class videos. Every day next day you will be having day 1 day 2 videos will be available here in the previous classes.
Okay, sir.
Okay,
Sir,
today was
actually,
the
I have
day
not yet provided any. I paid the fees today. I joined today, so I'm
that's what I
not
mean.
yet.
See, in this dashboard there is a column called live course. When you
Okay.
log into your id, okay, when you
Yes.
log in the user id
Yeah.
which is provided to you, If you
Yeah.
come to the live course, you will find view all live courses. If you have been joined in silico drug designing, just click there. Or else, if you have joined for in silico drug designing with Python, go for start class. Okay. So at
Okay.
the down bottom, there is a start live class is available. Okay.
Okay. Yes, sir.
Just click this one, go for S. That will be redirected to you to their class. Okay.
Okay,
Directly
sir.
to the Google Meet. So every day this will be the procedure. So don't get confused. Okay.
Yes, sir. Thank you. Thank you.
So previously I want to say, but some of them were already known, I thought. That's why I have not explained you. But for you, in case Sampada, you were not there for the last two sections. So you can,
Yes, sir.
you just click this one. So you will find at this video.
Yes, sir.
Video will be
Thank you.
played.
Okay. Okay. Thank you, sir.
And for Kasturi and for Arvind, for you also the same thing. Is it clear for you all?
Yes,
Yes.
sir. Thank you.
Yeah, fine. So this is a procedure for everything. And for today's class, we have done the cluster alignment. And other thing, we actually we don't have this particular topic today also. But I just want to tell you, I just want to share. Today we were having only similarity searching, BLASTP, and sequence alignment. But I want to also teach you the phylogenetic analysis also. Okay. It's my interest to teach you. If you are interested, I go for that one. It's a mega software. If you
But
want, I will teach you. If not, it's not mandatory. I can close.
we'll go for that also.
Yeah. So whoever wants to, whoever has their lab, please download Mega software. Just click Mega Bioinformatics. If not, sometimes Mega means we'll find that Tollywood actor Megastar Chiranjeevi. That he'll get that names. That's why just click Mega Bioinformatics. You'll get that directly. The software will be downloaded. Mega also called as molecular evolutionary genetic analysis. Okay. So depend upon whether you are using CentOS, Linux, or Red Hat, or Mac, Windows, whatever it may be. Just go that one, the relevant information, Windows, and select the if you are 64 using 64-bit or 32-bit. Okay, if you want older version also, you can select that one. Go for download. Okay, after downloading, just install it. It is freely available. Okay. So let me go for Mega. So I have Mega 7. So I'm using Mega 7. So Mega 7 or Mega 10 or Mega 11, all are similar. Okay, all are similar. Don't get confused. So this is the Mega software. Okay. So once again, I just explained something to her, Sampada, for you. Let me show you something. So
Yes, sir.
if you want to see similarity between the alignment, you can use cluster software also. For cluster software, I will provide you the recorded link. You can use that one. For this particular Mega, I teach you now because we are running out of time. That's right. So I have given insulin in the UniProt database. UniProt is also called as Universal Protein Database. Here only the protein information is available. So in case like UniProt, up to now there are something called 113 sequences are available in different types of organisms. And you can also see the reviewed one, the scientifically approved one, where among them 95,000, there are 4,929 only. In unreviewed, which are not translated still, those are still in annotation. Those are still 90,184. In this also, you can able to find the humans were 1600, mouse were 1400, rats were 1200, and bovine were 710, zebrafish were 635. So I have selected each and every sequence. I want to see in different types of organisms the insulin's sequence, whether it is having any similar or any difference is there. I want to see how close they are. Are they how far they are distantly not close? I want to see them. At that condition, what I am doing here, I'm just gone here. I have selected human. One was a human, other one was a rat. Sorry, mouse. The third one was a Senora habitus elegans. The other one was pig, Succus scrofa. So these are the four things I've selected. So whenever you're selecting any sequence, so it shows you the 6-digit ID. This is the 6-digit ID. Even if you Google this ID, you will directly redirect it to your protein. Okay. So everything, all four IDs are belongs to insulin only, the protein, but the organism is different in all these insulin. Okay. So just come to this border to the left side of the display of the panel, the index. You can see the sequence. just click this sequence. So you will find this FASTA sequence. Okay, the FASTA sequence information. This is the uniprot insulin sequence information. Okay, you will find a sequence information. It has a length of 1367. Okay, it has a molecular molecular information. That means its molecular weight was something like 1,54,793. It's been last modified in August 1, 1988. Okay, so you just go for FASTA. Just by clicking the FASTA, you will find the FASTA sequence. So you have to select this entire sequence. Okay, after selecting this entire sequence, create a folder. So after creating a folder, okay, just delete these all things to avoid the confusion, or else no worries. I just delete all this. I'm just opening the file, just paste it here. Okay, for in case for when you're performing mega, it is also same procedure. So I'm pasting all the different types of organisms. I'm pasting the pig. There is this one belongs to pig. Okay, the other one was Cinereus elegans. Is it clear till here for all of you?
Yes, sir.
Yeah, fine. Then go for file. Don't save it. Save as. Okay, name it as mega. I'm just naming as mega to avoid the confusion. Mega as FASTA format. Okay, whenever you are saving any type of document, okay, the type of document when we have saved copied it was text document, but when we are choosing for mega software, when you're uploading any sequence in our tool, okay, you have to save it in the FASTA sequence. Okay, that is the extension called .fasta. Whenever you are ending the name, you should have to include the double quotations also. Got it? Okay, I'm just saving.
Yes, sir. Yes, sir.
I just saved it. And see, let me check whether it has saved in the name called mega and with the document called FASTA. Got it? Now what I'm doing, I'm just opening mega software. Already was opened. It has been opened. I'm just going for file, open a file section. So where was our file? It is in the drug designing. So you can see here the FASTA. Got it? So you want to analyze or you want to align? We are aligning our sequence. Okay, but we can't able to generate the output formats like PIR, these all things as we done in cluster. So I'm just aligning the sequence. So you will find here all these things. So you can find all the sequences will be has been aligned. So now I want to align protein. So you can find here the cluster W, and you will also find muzzle here. Muzzle is also for aligning, and align will be the cluster X is also for align. So we are all familiar with W selection. So we align the selected cluster W. So I just select this one. So go for OK. So it has aligned. So now you can see up to where it has been aligned, what are the gap penalties were also available. Okay, I have aligned the data. Just tell me, I'm getting resound your voice, Arvind. Can you keep
Sir,
your
is it okay,
mic?
sir?
Yeah, tell me.
Sir, actually, like I have something called Mega X, sir, in my desktop. Is
And
it the
that
same?
was, yeah, same, exactly same. Mega X is also called as the alphabetical symbol, the mathematical symbol X stands for 10. It's a 10th software, updated software. As you see, this iPhone 10, iPhone 4, something, the names will be different, na? The versions.
Oh, okay, okay.
That's the difference.
Okay,
Is
sir.
it okay?
So whatever we did it through Custal X, that's
Yeah,
the
everything was
same.
fine. You can do there also. Okay.
Yeah, yeah. Okay, okay, sir. Okay, sir. I
Yeah.
can. Okay, thank you, sir.
Yeah, after aligning, after selecting cluster legs, you have aligned your desired protein of 4 sequences. Just go for data. Okay, just go for save section. sorry, just go for data, just export the alignment in mega format, not in FASTA format. It is already there in FASTA format. We want in a mega format because the mega software, it only takes the mega format. Okay, it never takes other format like FASTA or other things. For alignment purpose, we have given the FASTA format. When you are going for, when you want to create any tree, or when you want to create any phylogenetic analysis, so you can able to align the mega it will take only the mega format as the input. Okay, so I just gone for mega format. So the name was is also in mega only. It is saving in the same file. Just save it. So it is asking some title. Just give it as something like mega or mm. I saved it. So let me check whether it has saved or not. So it has saved, right? In mega format, that is MEG file. The document is in MEG file and it is also in mega. So you see the icon is in mega now. Now it has changed. Let me show you. Now the icon has changed, right? It's showing the mega software tool only. As how the PyMol shows, this is also showing in mega. Is it clear, Kasturi, Preeti ma'am, Sampada, Arvind?
Yes, sir.
Yes.
Fine. Okay. So now
Yeah.
what I'm doing? Now what I'm doing? See here. Just close this type of this file. This dialog box. I just closed, which is has been opened. Now I want to see the distance between that particular protein of all the four proteins. How far they are distantly related. Just for compute pairwise distance. So it will ask only the mega file format what you have saved. One minute. So okay, let me see this one. So when you come for you are constructing a tree, a phylogenetic analysis. In phylogenetic analysis, there are different types of tree alignments are available. Those are UPGMA method, that is NJ method, that is maximum likelihood method, and also maximum parsimony tree method. So when it comes to the UPGA method, you want to find any nodes between one tree to other tree, or you want to see any close similarity, then you use the UPGA method. When you see the NJ method, that is called neighbor joining method. That neighbor joining tree is also called as, which is very close, distantly close. So at that particular criteria, we go for NJ method. Most probably that when we are constructing any tree, only that these two methods are very probable. Most probably they will be using. So I choose the UPGA method. So go for yes. So this is coming the other one. So now I show you. Previously it was not coming. So see, you have to go for phylogeneity, go select the UPGMA method, and it prompts you the active data is would like to use the currently active data, because we have done the alignment which we have said in mega format. It is asking that is it the same one? Yes, I'm asking yes. So it will ask the default position, what type of model method you were used, and what is the statistical method you have used, that is UPGA method, the analysis, and what is the substitution type, whether it is amino acid or DNA, it is asking you. So all things will be in default, and go for compute. Compute means it is asking you to go for execute. We are going to execute the tree. After you are executing, you are going to find the difference, which are those are having how far they are similar. And if you want to represent the tree representation in different method, so go for selection here. So you can also select this method. If you want to select in rectangular method, you can select rectangle. If you want to method straight method or curve method, also you can select. You can see the curve method here. Okay. So now you can also select in a circle method also. That is also available. So you can see this one, the circle method, or else if you want to see in traditional method, rectangular method, you can go there, that one. But I want to see in straight method. This makes us very easy to understand. Okay. So now you see here the sequence length is very short when compared to Sasaskrafa. And these three sequences are having the larger length. That's why these came alignment has came in one place. And you will see here the ID. You have chosen the UniProt ID and the organism name and the protein name. Okay. And now the interpretation is where the important thing we want to understand. So you can find which are very close. You can see Homo sapiens and musculus and Sasuscrofa. So you see these both are very close similar, Homo sapiens and mouse. When it comes to the Homo sapiens and mouse, Caenorhabdians and Helibranchs, these both are very close when compared to humans. But in case like Caenorhabdians and mouse, Sasuscrofa, these are very close. And Sasuscrofa and Homo sapiens having that distantly related, but not very close. Are you getting what I am saying?
Yes, I got it.
What about others?
Yes.
Distance is the base for the.
Yeah, distance was the base where they are not very close.
Okay.
This is also it's a similarity. So similarity, how far they are very close, we are just seeing. Got it?
Yeah.
This is the end of your class. If you have any doubts, you can clear. You can take the screenshot and can paste it in the your publications if you want to go for the phylogenetical analysis publications. And similarly, you can use the other tools also. There are something for distance method. If you want to see distance method also, you can see there. You can able to find the distance between how much distance is there between one organism to other. These are all things also you can see.
Sir,
Yeah.
why to always save mega dot fasta files in inverted commas?
Inverted commas means string. We are asking to save. We are asking the string operator to save that particular position only. We are not asking the outside file to save in that string. String means if you have familiar with the programming languages like C, C++, or Perl, or something like R, Python. This all the output which executes in the string format only always. That is called string operator.
Okay.
Okay. What about you, Sampada? You are from which background?
I'm from botany background.
You are from which place? What you are doing now?
I'm from Maharashtra, Pune.
Mm.
I did my MSc botany from Savitribai Phule Pune University.
Okay. Now you are doing pursuing MSc or you are doing
No,
English?
I have completed it.
That's nice. Okay, fantastic.
Yes.
Oh, what about others? Is there any doubts to be clear today? Tomorrow we have a section called hands-on demonstration, homology modeling. That is called modeler software. So don't get confused. Don't get hurry up to download these softwares for tomorrow. And don't say me I have not downloaded. Please sure you have to download and come. Okay, you have to download it the modeler software.
Now we have to download it.
Not now. When you're coming tomorrow section, please download it. Okay.
Okay.
Just go for modeler software.
Okay.
And select the version which you are going to downloading.
Okay.
So if you have downloaded, just ping me, then I'll send you the license key. If you have done, if you are installing, then only I'll send you. Until and unless if you don't do, I don't send you the license key. That
Okay,
makes
sir.
sure you are doing work. You are doing some work. I will understand. So tomorrow, if you want to build any model, a particular three-dimensional model, so you have
Where to ping you, sir?
Yeah, you can ping me, then I'll send you the license key. If not,
Where on WhatsApp or?
yes, WhatsApp also it's okay. And also the other one was Python molecular tool. You have to download other tool was Python molecular tool, MGL tools. We call them as MGL tools. It will be finded here. Just see here.
Okay, sir. I'll download that also.
That one was modeler. and the other one was Python molecular tool. Go for downloads. So you can select this one. Okay.
Yes.
After that, the other one was Python. Okay. You have to download the latest version Python. So what here in the downloads option, you will be finding the Python 3.10 version. You have to download this version.
Okay, sir. I'll do it.
If you download, it will automatically redirect you to the download. Okay.
Yes, sir.
Is there any doubts to the anyone regarding the in downloads or any installation? Just
No,
ping
sir.
me. We will just rectify it. Okay.
Okay, sir.
I think. Are you feeling interested, or you are getting any bored in these sections? If not, I will just get modify anything else if you feel bored.
No, sir. I'm interested in these.
What
things.
about Arvind, Kasturi, and Preeti ma'am?
Yes, sir. Class is so interesting.
Is
Actually,
it better, or you have
yeah,
any
yeah.
doubt? You are getting bored or not understanding?
No, no, sir. Actually, I'm acquiring something new.
Okay. Hope you are
Interesting
benefited,
for
right?
us.
Yeah,
Yes,
yeah.
sir.
What about Preeti ma'am? Arvind?
The thing is, actually, it's interesting only, sir. The thing is, I have my exams, so I couldn't get time to practice only, sir.
Okay, no problem. All the sections
The
will be
recording
available.
sessions are there. The
Okay.
recording sessions are there. When during Saturday and Sunday, I will practice, and if there's any doubt, I will ask.
Okay, fine. I'll provide
Actually,
you
the
all the
signal
recordings.
interrupted when we were talking the previous bit of conversation. Can you repeat it again?
Yeah, are you
Just a
understanding
minute.
everything? Are you
Just a minute before you are asking something. That's what.
you are feeling bored, or you are not? You are feeling interested or not? We just want to know it from your side, because I want to make it modify myself when I'm going for my demonstration. These all things.
Yeah, it's good.
Okay, that's why I just want to trying to understand your side also. If you
Yeah.
are okay, means then I can able to go ahead.
Fine. This is fine.
Yeah, okay, then I'll just stop recording. If you have any doubts,